Good day, folks. This is the question paper, the November 2030. This is a very interesting question paper. It says the diagram below shows a galvanic cell operating under standard condition. The cell reaction taking place when the cell is functioning is. So this is the net cell, right? And the net cell, it has a chlorine ion and a gold ion, produces the chlorine gas and the gold, right? Now, if you look at the standard reduction potential table, even though I do not have the entire, there's no gold, which is the AU there. So here, it's going to help you to, what is going to help you here is the oxidation number, assigning the oxidation numbers here. So if you look at this side, we have the chlorine gas half cell and the chlorine half cell, and then here we have a gold half cell, right? Fortunately, the chlorine, we do have it in the period in the standard reduction potential table, but we do not have gold, so we're not going to know which one is oxidizing and which one is reducing. But guys, if another thing that is unusual here, we normally have the external circuit, or the external in the external, which is the external circuit, we normally have that, which is the voltmeter only, or the ammeter that is connected there. Now we have the bulb as well, right? We have the bulb and the switch there. Now let's first start and see which one is oxidizing between the chlorine and the AU. So the oxidation number for chlorine is -1, and for gold is +3. So remember, the oxidation number, it's the charge, if it has the charge, and it's 3, right? And then for chlorine gas, it's 0, and for gold is going to be 0 there. So if you look at the oxidation number for chlorine, the oxidation number from -1 to 0, that means the oxidation number, there is an increase. There is an increase in oxidation number. So if there's an increase in oxidation number, that means that there's an oxidation that is taking place in chlorine. That means chlorine is oxidizing. Let's look at the AU. The AU, we have an oxidation number of 3 to 0. From 3 to 0. This means that the oxidation number, there's a decrease. That means gold, the gold ion, there's a reduction that is happening there. That means it's losing electrons. So what is going to happen here? It means the electrons, they're coming from there to there. So the chlorine is giving electrons to the gold, right? So let's look at the circuit, guys. If the circuit is open, the switch is open there, the electrons are going to move in that direction, right? And get there. But now if this switch is closed, the electrons are going to move this way to that. But there will be a voltmeter reading there, right? Now it says when the switch is open. And another thing, guys, this resistor, which is this bulb, this is a bulb. And this bulb, it acts as an internal resistance. It acts as an internal resistance, right? So if the battery, remember guys, this is a battery. Now this type of battery, it has an internal resistance, right? So if the switch is open, that means the internal resistance it does not get the internal resistance, it does not get the voltage. So this is going to read what? The EMF. But now when it's closed, when this switch is closed, this is going to read what? The V external, because there's a voltage drop due to the internal resistance. Okay, let's go. It says when the switch is open, the initial reading, it's 0.14, which is when the switch is open, that's the EMF. So when the switch is open here, so this internal resistance is not going to use any voltage, so that's the EMF. Now let's answer the question. It says name or the formula of the oxidizing agent. In the net cell here, the oxidizing agent, you get it in the reactant. So the oxidizing agent is this one. It's the one that is reduces, the one that gains electrons. It's the oxidizing agent. So it will be Au to the 3 plus. It's Au 3 plus. Or you can say it's a gold ion. Don't ever say it's Au. That's not Au. And don't ever say it's gold. It's gold ion or Au 2 plus. Write down the half reaction which takes place in an anode, which is the anode is this side. This is an anode, and this one is the cathode, right? The reaction that takes place in an anode, it's a Cl minus, two of them, which gains no, which we can even look at it here. Do you see? We start with this one and then arrow and 2 electrons and gas. So it's going to be that and arrow and gas and then 2 electrons, right? That one is oxidizing, right? It's oxidizing. We look at that way. Yeah, that's correct. And then the cell notation. The cell notation, guys, you must remember. Here we have platinum, right? We have platinum there. So if we have platinum, the platinum there acts as an electrical conductivity. We must involve the platinum there. And that is very important with the cell notation that has a gas. So the cell notation there, it's going to be platinum in a solid state. And then we'll say there's a chloride ion. There's a chloride ion there. And when you say there's a chloride ion, you need to show the negative sign there. And then state change, and then there will be a chlorine gas, right? A chlorine gas, and then salt bridge. And then it's going to be a gold ion. And then a gold there. That's how you write that, guys. You do not worry about the state changes there. Now it says calculate the standard reduction potential for Au. Remember, Au is not in the table. So let me write 8.2 here. So you'll say E cell equal to E cathode minus the E anode, right? And then we're given the standard reduction potential table. When the switch is open, it's 0.14, and then the cathode is gold. So we are looking for gold. Gold is the cathode. So we are looking for gold. So the anode here, the anode is chlorine, and chlorine is 1.36. It's positive 1.36. So we're going to say 1.36 there. And then your math, when you do the math there, that means this is going to go to this side and be positive. It's going to be 0.14 plus 1.36. It's going to be 1.5. So the standard reduction potential for Au, it's 1.5. Then let's answer the last question. If the switch S is now closed, the bulb lit up. So this switch is closed and the bulb lit up now. That means this bulb used one of the resistance. So there will be a reading here, will no longer be an EMF. It's going to be the V external. So it says, how will the reading on the voltmeter now compare with the initial reading of 0.14 is write down only larger than, smaller than, or equal to give reason for your answer. So the answer there, it's going to be smaller than. Why is it smaller than? It's smaller than because there's a voltage drop. There's a voltage drop. There's a potential difference drop due to the internal resistance. Remember, guys, when we close the switch, there's a current that is moving there through the external circuit. There will be a voltage drop, right, due to the internal resistance, or we can say due to the V lost, due to the lost volts, due to the lost volts. Guys, I hope that makes sense. Cheers. Bye.